Okay, so today we're going to be doing adding and subtracting fractions. This is also kind of our first fraction lesson, so we're going to start with just a quick little introduction. It's it's a simple idea that a lot of people kind of get tripped up with, and it can be complicated. It can look scary, but once you break it down, once you understand it, it's very simple. All a fraction is, honestly, it's just a piece of a whole number. Honestly, if we had one, the number one, if that's a full, half is 50% of one. So like I said, it's just a piece of a whole number. And let me get this erased. Okay. So like I said, it's a piece of a whole number. There are several different ways you can represent it. Several different ways to represent the idea of a fraction. This is probably the one you're most used to, just a number over number, 1/2 in this case for a half. Like I said, that's just the traditional way. You have the top number, which is called a numerator, and then you have the bottom number, which is called a denominator. And so that's pretty much it. It's just your numerator on top, denominator on bottom, and some little kind of hash mark in the middle. That's how you would write out a fraction numerically. Now, visually, sometimes, like I said, visually, you can see it physically. If you had a chocolate bar and it was broke during shipping or something and cracked, so you open it up and it snaps in half like that, right down that white line, right there, splitting the letters. It's just in half. That's the same amount that's gone as that 1/2. But now instead of writing it out as 1/2, we see it visually. We see half of that chocolate bar. But it's the same amount. It's just like on this number line. Just like from elementary, you have 0, you have 1, 2, 3, and then -1, 2, 3. It could be like that. If this is a whole hop, if this is 1, then half is this right here. This little hash mark in the middle is half. Is our 1/2. Or we could just write it out as 1/2. But whether we did it numerically or visually or on the number line or wrote it out in words, it's still a half. The amount does not change. It's just how we look at it, how we present it. And so some fractions are equivalent. And what that means is there are different fractions that can be equal in percentage, because, like I said, the percentage is the same. It's still a half. We're talking about a bigger number on the bottom, but also on the top. So like I said, this half right here. You can think about a pizza. That's probably the easiest way to think about something like this. If we got a pizza, and it's one of those frozen ones that's not cut, we got to cut it up ourselves. We can cut it any way we want to. So I just cut it right down the middle, 2 pieces. And I eat 1 piece. So this piece is gone now. And I got 1 piece left. All right. And then say my brother gets home and he gets a piece out of that freezer, but he cuts his up into 4 pieces. Okay. He cuts his up into 4 pieces, but he eats 2 of them. So he eats both of these pieces, he's got them gone. And then say my other brother gets home and he said, well, if y'all are eating pizza, I'm gonna get one too. But he cuts his up into 6 pieces. Now he's cut his up into 6 pieces, but he's ate more of them. He's eaten 3 pieces. So like I said, what you notice on this 1/2, like I said, I got my piece, I'm gone. My brother got his 2 pieces. Wow. He ate his 2 pieces, he's got that gone. My other brother come and he ate his 3 pieces. So each one has eaten more than the other, but the same amount is gone. Because whether we cut it up into 2 pieces or 4 pieces or 128 pieces, if we eat half of it's gone. The amount does not change. And so like I said, that's what you might hear when we talk about simplifying fractions. That's what that would be. Because 2/4, so we can simplify that down to 1/2 because the same amount is gone. Like I said, you would just divide this, they both divide by 2, and that would simplify down to 1/2. It would be the same thing right here. Both of these divided by 3. And so that's how you would simplify fractions. That's kind of the basis of it. So now that we understand it, let's talk about how to add and subtract and go a little bit deeper with them. And so like I said, we're gonna start off with the easy one with the like denominators. Like I said, that's gonna be the easy one. So we are just gonna, all you do is just add or subtract your numerators. If your denominators on bottom are the same, you just add your tops and you're good. So this one right here, we have got 2/6 plus 3/6. So 2/6 plus 3/6. All right, so like I said, our denominators on bottom are the same. We have got, like I said, we got pieces again. Both of them are cut into 6 pieces, but this one has 2 pieces and this one has 3. So all together in both of them, how much are we talking about? So like I said, you would just come across, our denominator is the same, so we just carry it over, because we're talking about 6. And now we would just add our numerators. So 2 plus 3, which is gonna be 5. And so 5/6 is gone. If we cut it up into 6 pieces, like I said, we got this one left over. So like I said, if your denominators are the same, you just add your tops, and life is good. But if your denominators are unlike, we got 2/3 plus 1/6, it's still easy, but we gotta do a little more work. So the first thing we're gonna have to do is find the least common multiple of our denominators. And so, like I said, I'm not sure if you remember this, if you've gone over this, but we'll go over it real quick. Our multiples are just, number 3 times 1 is 3, 3 times 2 is 6. And so 3 and 6 are both multiples of 3. That's just how many times it goes out. So like I said, 3 times 2 is 6, times 3 is 9, times 4 is 12, okay? So now, like I said, we have to find the least common multiple of both our denominators. We got 3 wrote out before, so now we've got to write out the multiples of 6. And like I said, you see how we do this? You may be doing now in your head, well, 6 times 2 is 12, times 3 is 18. So let's see, like I said, times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 24. Okay. So now we've got some multiples of 3 and 6, and so now we have got to find the least common multiple. So we got to find, there's some, like you can see, well, we got 12 over here, and we got 12 on both of them. So 12 works. 12 does not work. 12 is a common multiple. We got to find the least common multiple. And so we will just find the smallest number that would go into both of them. Now 6 times 1 is 6, 3 times 1 is 3, but 3 times 2 is 6 right here. So that's going to be it. So we have got our least common multiple, which is 6. So our end result, our denominator is going to be 6. We can go ahead and write that down. So now we got to look. Like I said, we got 3 and 6. So what do we need to do to 3 to get to 6? Like I said, we just counted out our multiples. You multiply it by 2. So we're going to multiply this 3 by 2. And we're going to repeat that step to our numerators. So 3 times 2 is 6. So we're just going to do it right here. 2 times 2 is 4. So 4, 6 plus 1, 6. So see, our denominators on bottom are even now, because we found our least common multiple. We got them even. 3 times 2 is 6. What we did to our bottom, we did to our top. Got 4, 6 plus 1, 6. Add across the top. 4 plus 1 is 5. Like I said, it's simple. it looks frustrating with all the hashes and the numbers and pieces and all and multiples. It's not that hard, I don't think. And so we've got some examples right here. We're just gonna run through them real quick. We've got 1/4 plus 2/3. So 4 and 3. Now 4 and 3 don't have any common multiples. We're stuck right here. So what we're gonna do is multiply them by each other. So we multiply 3 by 4 and 4 by 3, which will give us 12. Now remember what we do to the bottom, we gotta do to the top. So this 1 is gonna be multiplied by 3, and this 2 is gonna be multiplied by 4. See this bottom to this top, this bottom to this top. So 1 times 3 is gonna be 3. 2 times 4 is gonna be 8. 3 plus 8 is 11 twelfths. So that's it. Number 2, see we have like denominators, so we can just add across the top. 54 plus 26. 50 plus 20 is gonna be 70. 6 plus 4 is gonna be 10. So that is gonna be 80 100ths. Now, is this simplified? Can we simplify number 2 down any? And this is recorded, I can't hear you. But yes, we can. 80 and 100 are both divisible by 10. And so divisible by 10, you would just take that 0 off. And it's 8/10. 8/10 is equal to 80 hundredths if we divide them by 10. So simplify, that would just be 8/10. Number 3, again, our denominators are equal, so we just write it down. That's 12, add across, 3 plus 6 is 9. Well, let's see if we can simplify this one again too, because 9 is divisible by 3, and so is 12. So 9 twelfths, 9 divided by 3 is going to be 3. 12 divided by 3 is going to be 4. And number 4 over here, we got some subtraction for these. It's like I said, it's the same principle, whether you're adding or subtracting, we set it up the same way. Our denominator is the same, so we would just subtract across the top. 14 minus 9 is going to be 5/15. Oh wait, we can simplify that down into, like I said, 5 divided by 5 is going to be 1. 15 divided by 5 is going to be 3. So that simplifies to 1/3. Number 5, we have 4/6 minus 4/8. Again, 6 and 8. Yes, let's see, we got 6 times 1 is 6, times 2 is 12, times 3 is 18. Let's see, let me get a little room down here. 6, 12, 18, 24, 30. And so we have 8. 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. 8 times 4 is 32. 8 times 5 is 40. Well, let's see. I got 24 right there, and I got 24 right there. So, of the 24, like I said, 6 times 4. 4 times 4. And then 8 to get 24 multiplied by 3. So multiply by 3 to the top. 4 times 4 is 16. Minus 4 times 3, which is 12. 4. So 4 24ths, well, let's see, we can simplify that down, because that will divide by 4, and so will 24. And that is 1/6. And so number 6 right here, last one. Let me get my multiples out of the way. We have 5/7 minus 3/7, which again our denominator is the same, so we would just subtract across. 5 minus 3 is 2. And that's it. That's how you would add and subtract fractions with like or unlike denominators. You should be able to handle any fraction you come across now.